Hey, we're going to look at what we call the double angle identities. That's right, I just talked as I walked away so I could grab a calculator. We're going to talk about some double angle identities here. Where's my clicker? There it is. Here we go. So, we've got some double angle identities. Now, notice this is when we have sine of 2 times some angle. So, the angle could be like, we could have sine of 100, and we could write that as sine of 2 times 50, so we could use a double angle identity or so on. But sine of 2 theta is 2 sine theta cosine theta. Well, you can see all of these. Now let's see some ways we can use them. Here it says, well, we're going to evaluate expressions using our double angles if sine of theta is equal to negative 7 over 25 on the interval from pi to 3 pi over 2, find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. Really just an exercise making sure that we can use these identities, okay? So we've got 3 answers we're looking for. I'm going to create answer boxes for us so we can just plop the answer in there once we get it, and that'll be nice. We know where we're going to put our answer. So if we want to first find sine of 2 theta, we should probably be thinking about our double angle identity for sine of 2 theta. Sine of 2 theta is equal to 2 sine theta cosine theta. All right, we check it out. That makes sense. That works. All right, now, in order to get this, in order to get sine of 2 theta, we don't just need sine of theta, which we do have. We also need cosine of theta. So how are we going to get that? If we have sine, we need cosine. Well, there's 2 ways you can get cosine. I can think of 2 ways off the top of my head, but I'm sure there's more. The first one is we could just simply draw a triangle, say, hey, there's theta. If this is sine of theta, well, sorry, we should probably think about that interval. On our unit circle, pi to 3 pi over 2 is from this x-axis here at pi to 3 pi over 2. We're talking about this quadrant. And so this angle right here, our reference angle using the x-axis, here's our right triangle we're thinking about. Well, sine is opposite over hypotenuse, negative 7 and 25, because it's negative 7 because we're going down 7 right there. So from that angle, over 7, 25. And we know what quadrant we're in. We're in the 3rd quadrant. Both the sine and the cosine are going to be negative. So no matter what we get for our cosine, we know it's going to be negative. We can use Pythagorean theorem to find that 3rd side of our right triangle, and this ends up being 24. But we know it's 24 going in this direction to the left of our origin, so we know that's a negative 24. So once again, I know you're thinking, wait, how do you get that 24? Pythagorean theorem, that's a 24. Double check it if you don't believe. So right there, using our triangle, we can see that cosine of theta is a negative 24 25ths, and just in case we need it, tangent of theta, tangent of course, opposite over opposite over adjacent, it is 7 over 24. So we have these if we need them, not the answers to the problem, because this is tangent of theta, we want tangent of 2 theta, and so on. Back to the problem at hand. We want sine of 2 theta, so we plug in sine of theta, which is a negative 7 over 25, cosine of theta, which we found, which is a negative 24 over 25. When we multiply these out, a negative times a negative, of course, is a positive. This comes out to be a 336 over 625. This won't reduce. Sine of 2 theta is 336 over 625. Well, now that we found sine of 2 theta, I'm going to erase this to give us room. Then we look for cosine of 2 theta. Cosine of 2 theta. Well, it is 2 cosine squared theta minus 1. Double check. Yeah, I was right. Look at that. All right. Now there's other ways to get cosine of 2 theta. You can pick whichever one you want to use. There's other ways to get cosine of 2 theta. This just seems to be the easiest one because there's only one thing we have to input, and that's cosine negative 24 over 25 squared. Cosine of theta was a negative 24 over 25, but we have to square it. Minus 1. We can type all this in the calculator. 2 times 24 over 25 squared minus 1. It'll change it to a fraction for you. That's 5/27 over 625, and that is reduced. Finally, for tangent of 2 theta, well, first of all, we could, because we have sine of 2 theta and we have cosine of 2 theta, we could do sine of 2 theta over cosine of 2 theta to get tangent of 2 theta. That is possible. We can just do the sine over the cosine of 2 theta to get tangent of 2 theta. That's possible. But for the fun of it, I'm going to use our double angle identity for tangent, not squared, tangent 2 theta. We do take 2 tangent theta over 1 minus tangent squared. And we just plug things in. Okay, we just plug them in. Because we know tangent of theta is 7 over 24. On the bottom we have 1 minus 7 over 24 squared. We can type it in. 2 times 7 over 24. That's a 7 over 12 on the top. On the bottom, 1 minus 7 over 24 squared. That's 527 over 576. Fraction divided by a fraction. You can just type it in the calculator though. 7 over 12 divided by our answer. We get 336 over 527. Okay, so several ways to do this. There's the path could have split several times, and some people might want to find different things different ways, but we should get those values as long as we're using these identities. Finally, earlier I showed how to get cosine and tangent using this triangle. That's not the only way we could have done this, and I like to show multiple ways. So if you didn't like this whole triangle thing and you wanted to use another method that we have used, if we have sine, we can find cosine using our Pythagorean identity. Sine squared plus cosine squared equals 1. So we could take sine, which is a negative 7 over 25, and square it, plus cosine squared, whatever that may end up being, and set it equal to 1. 7 over 20, this would be 49 over 20.
Morgan and Taylor Verdier, Landon Davis, Haley and Cadence Reeves. Haley and Cadence Reeves, Landon Davis, Morgan and Taylor Verdier, Cadence
We could subtract.
Landon Davis. I need the Simridges. They dropped in with us today. There they are. Luke and Lee Ledden. Luke and Lee Ledden.
The afternoons. All right, we get c squared equals 576 over 625. If you're wondering how I got that, 1 is 625 over 625 minus 49 over 625. We get 576 over 625. You take the square root of both sides, and we get a positive or negative 24 over 25. And you think, how do we know which one it's going to be? Is it positive or negative? We know what quadrant, though. And in the third quadrant, cosine must be negative. So that's another way we could have gotten cosine using our Pythagorean identity. Some people like to draw a triangle. Some people like the Pythagorean identity. Who am I to tell you what to do? They both work.